43. Free fall. On the moon, the acceleration due to gravity is 1.6 meters per second squared. A. If a rock is dropped into a crevice, how fast will it be going just before it hits bottom 30 seconds later?
Okay, so for this problem, you're given the acceleration, it's 1.6 meters per second squared, and before it hits the bottom is 30 seconds. So A is equal to V prime, so you have to take the antiderivative of the acceleration, which you would get 1.6 t plus c. Because you want to find c, you set time equal to 0, and you find that t is equal to 0. And when t is equal to 0, you would normally put it back in this equation, but since it's equal to 0, it doesn't matter. And because t is 30 seconds, your new equation is v equals 1.6 t. So you plug in 30 seconds for t, and you get 48 meters per second.
How far below the point of release is the bottom of the crevice?
So this is part B of the same problem. You're still given the same things, except in the last question you found that the velocity was 48 meters per second. Time is still 30 seconds, and the acceleration is still 1.6 meters per second squared. So your equation that you used in the last problem was 1.6 t. You take the antiderivative of that, so you add 1 to the to t, and then you divide by the new exponent. You get the new equation, distance is equal to 0.8 t squared plus c. You plug in 0 for time to try and solve for c, and you get c is equal to 0. And then, because time is 30 and you want to find out how far it fell after 30 seconds, you plug in 30 for t, and the distance it fell is 720 meters.
If instead of being released from rest, the rock is thrown into the crevice from the same point with a downward velocity of 4 meters per second, when will it hit the bottom, and how fast will it be going when it does?
Alright, so since it's a continuation of the last two parts of the problem, you know acceleration equals 1.6 meters per second squared, time equals 30 seconds, and then d equals 720 meters. So now that you have a starting initial velocity, you go through the same position, or same steps, but now instead of 0, you have 4. So to solve for c, you get 1.6 times 0 plus c equals 4, so then c equals 4 for velocity, well, the equation. So now, since you want to find the distance as well, c equals 4. So since you're trying to find how long it took, you're going to take this equation, and you're going to do the antiderivative of it again. So you get 0.8 t squared plus 4t plus s equals dt. So then you once again want to solve for s. S is just a different variable than c, but it's the same exact thing. So when you plug in 0, you're going to get 0. So s equals 0. And now you know the distance is 720. So you plug in 720 here, and then you subtract it. So then you get 0.8 t squared plus 4t minus 720 equals 0. Alright, so now to finish the problem, you have this equation, and you want to solve for t. So it doesn't factor, unfortunately. I tried. I cried after I realized it didn't. And you got to use the quadratic formula. So you got your a, b, c. So it's negative 4 plus or minus the square root of 4 squared minus 4 times 0.8 times negative 720 divided by 2 times 0.8. It all simplifies down to this. So I simplify it again. And these are the final answers you get because 2,320 isn't a perfect square. You can't have a negative time, so that makes the answer 27.6 for time. So now to find the velocity, you plug back in the time for the velocity equation, and you get 48.16 meters per second.
There you have it.
Bull crap! In exercises 31 through 34, find the function with the given derivatives whose graph passes through the point P.
Okay, so this is actually 34, and you're given the derivative, so f prime of x, and it equals 2x plus 1 minus cosine x, and then they give you the point 0, 3. So then the next step is you have to find just the original function. So what you have to do is you just take the greater exponent of which is already there, so this is actually 1. So you just take it 2x squared, and then you just divide it by the new exponent, so divided by 2, and this actually cancels. So you're just left with x squared. And then x, or 1 is the derivative of x, so that's easy. And then the derivative of negative cosine is negative sine x. And then you have to include plus c. But we actually know the point. So what we do is we set this whole function equal to 3, because that's what the point is, 0, 3. So when you do that, you set x equal to 0. There's that, and then that's y. So it's 3 equals 0 squared plus 0 minus sine of 0 plus c. So really, all of this is just 0. So you're just left with 3. So c equals 3. So then you know c, so all you have to do is just rewrite the equation where f of x equals x squared plus x minus sine x plus 3. And that's the original function.